The question says that a turntable rotates at 40 rpm. The body can just stay on the table at a distance 12 centimeter from the center. Find the coefficient of friction. So the turntable is rotating at a velocity at 40 rpm, revolution per minute. So we can have omega, the angular velocity, from here it will be 40 times 2 pi over, we want it in seconds, so 60, so this much radian per second. So that's the angular velocity, and the body just barely, it says it just can just stay on the table at a distance 12 centimeter from the center. So if we think here, the radius is 12 centimeter and the object barely stays there. That means the friction between the object and the table is barely enough that it can is enough so that it can stay on the table while the table is rotating 12 centimeter from the center. It can stay at 12 centimeter distance from the center. So that's R here, which is 12 centimeter, and the frictional force gives the centripetal force, and we have to find the coefficient of friction. So the frictional forces, which is the centripetal force, will be coefficient of friction times mass times g, and the centripetal force, which is the same as this one, is mv square over r. V is m omega r is the velocity, which is angular velocity times radius, so that much. So we can find, we don't need to find velocity here, we can just use the angular velocity value which we have. So this is becoming m omega square r. So we have to equate these two, mu omega g mu mg equals to m omega square r, this much. So we can see that m is getting cancelled. So basically we don't need to know the mass of the object. So mu will be omega square r over g. So we have everything. This is 40 times 2 pi over 60. This is square, so 40 square, 2 pi square, 60 square times 9.8, and r is 0.12 because it's in centimeter, we have to convert it. So once we calculate this one, we get this one as 0.215. So that's the coefficient of friction.